Hello everybody. The last time I demonstrated the sensitivity to UV light for glass J305 Geiger-Müller tubes, and these tubes proved to be quite sensitive to light, even quite some distance away, even more than 1 meter. At the end, I quickly tested an SI-8b pancake tube that too reacted to UV light. But thinking again, it didn't react quite the same way. The UV light has to be very, very close for it to react. Let me show you. I bring the UV light very close. Here we are about 5 centimeters. Nothing happens, it's still reading background. But if I come closer, all of a sudden it goes through the roof. And this is not exactly the expected behavior. It doesn't tick faster, it just goes through the roof in one go. And it does that with both UV lamps. But this made me think that this is not sensitivity to UV light, but it's some sort of electromagnetic interference that only happens at a very, very close distance. So I want to find out if this is the case and if this tube is sensitive to UV light, or if I was fooled by some electromagnetic field coupled in a magnetic or electric way. But first, let me show you how this SI-8b reacts to the same quantum pendant we used last time. And if we approach it, we see that the tick counts increases and increases and increases, but it does not go through the roof at once. And if I move it away, I see the tick count gently going lower and lower. So this would be the expected behavior also for UV light. Bringing the UV light closer to the tube should increase the tick count gently, as this was happening for the J305 glass tube, and should not go up through the roof all of a sudden. So to test if there is electromagnetic interference, or should I say radio frequency interference, because UV light after all is also an electromagnetic wave. So to test if there is any radio frequency interference, I wrapped my Geiger counter into aluminum foil and I let an opening for the mica window of the pancake tube, protected by a metal mesh. And I let only the display, the LED and the power switch visible. And I did the same thing for the light sources. There is only a tiny window for the light to come through, leaving the light go through, but keeping hopefully the radio frequency interference inside. Let's first test if the tube is still sensitive to gamma radiation. And yes, it is. Gamma can still go through the metal mesh and the mica window of the tube and be detected. So the aluminum foil did nothing to against the gamma radiation. Let's now test the 365 nanometer source. It's here, it's on. Let me bring it in front of the tube as close as I can. No weird behavior anymore. UV light does nothing to this tube, at least 365 nanometers. Let's now test the 254 nanometer source, UVC, also on, in front of the tube. No more strange behavior, no sensitive to UV light So no, the SI-8b pancake tube is not sensitive to UV light. And this is also probably because the mica window is not transparent, it looks brownish, and this is probably a UV filter that keeps UV radiation outside the tube, while the J305 is clear glass and UV can go through. So is the SI-8b pancake tube sensitive to UV light? No, it is not. Nothing really happens. I apologize for the false positive of my last video. That was radio frequency interference, and now that we have the aluminum foil that shielded it away, there is no more effect of the UV light on this tube. I apologize for the false information I gave in the last video. So this is the correct answer. SI-8b, it's not sensitive to UV light. On the other hand, the J305 is indeed sensitive to UV light, because I could prove that light, even at a considerable distance, like 1 meter away, where the radio frequency interference is not strong enough, still was picking up UV. And we also see that the fluorescence of the little paper that I put close to the tube went in the same way as the count went up. So yes, J305 is sensitive to UV light, SI-8b is not. To be sure that what we observe on the J305 tube really comes from the UV light and not from radio frequency interference, we should also repeat the test with a shielded UV source and see if we observe an increased radiation. Now, shielding this thing is a bit tricky, because everything is almost exposed and I don't want to play with dangerous voltages, but still I want to try to make a better shield on this and see if we still get the interference. So this is what I came up with. It's not the prettiest thing, but it's wrapped the Geiger counter inside. Here is the battery, the tube is right here, and let's see if this is still sensitive to UV. I think it's clearly sensitive to this UV lamp at 365 nanometers. Take away the lamp, bring the lamp back. So the J305 is sensitive to UV light, and we were not fooled by radio frequency interference.